Welcome to the 12.1b, check your understanding. So everyone knows that cars and trucks lose the value the more they are driven. Can we predict the price of a used Ford F-150 if we know how many miles it has on the odometer? We have a random sample of 16. The number of miles driven and the price were recorded. Here's a computer output. Let's interpret and construct a 90% confidence interval for the slope of the population regression line. So we have the sample. It does have a slope. That's our statistic. It's a way to summarize something from a sample. And we want to estimate if we were to have every single Ford F-150 miles driven and price, what the slope would be there. So we have our computer output. Okay, let's do this. State, we have beta, the slope of the population least squared regression line for price, y, and the miles driven, x. Always good to define your variables. And we're talking here, beta is the population least squared regression line slope. Our statistic, negative 0.1629, and here's our confidence level. For our plan, we'll name the test and one sample t interval for beta. And we'll go through our conditions, and you can use liner to remember everything you need. First step, linear. The scatter plot shows a linear pattern, and the residuals show no leftover pattern. So the form of the scatter plot is linear. The residuals aren't showing any, they don't look quadratic or anything. It is an independent sample. Since we sampled without replacement, we'll use the 10% condition, and 16 is less than 10% of all Ford F-150s listed for sale. Normal, no strong skew or outliers in the residuals. That's from that histogram of the residuals. The equal standard deviations, the scatter of the residuals are around zero, or around zero is about the same for all x's. So when you're looking at the spread for any x, it's about the same. So you're not looking for it to get more spread as the miles driven increases, kind of looking like a tree or anything like that in either direction. And it was a random sample. We had a random sample of 16 trucks. For execute, we have our point estimate plus or minus margin of error. Make sure to write the general. Here's our specific. Here's the numbers filled in. This t test statistic will use degrees of freedom 14 since it's n minus 2. So you can get that 1.761 from the table. This is a 90% confidence level with degrees of freedom 14, or you can use inverse t with an area of 5% and degrees of freedom 14. Here we get our interval, and we'll make our conclusion. We are 90% confident that the interval from negative 0.21744 to negative 0.10840 captures the slope of the population least squared regression line for price and miles.